Hello everyone, and welcome to my presentation, my video on annuities. So, what is an annuity? An annuity is a sequence of equal payments occurring at regular time intervals. The payments can be deposits into an account, or they can be withdrawals from an account, or they could be payments on a loan. The periodic payment of an annuity is called the rent. We will use the variable capital R for the rent payment of an annuity. So capital R is equal to the periodic payment on an annuity. Please notice we are using capital R for the rent payment and lowercase r is used for the yearly interest rate. So little r is still going to equal the yearly interest rate converted to a decimal. Well, there's two types of annuities that we're going to see. One is called an increasing annuity, and the other one is called a decreasing annuity. An increasing annuity, sometimes called a growth annuity, is when the rent payment goes into an account and the value of the account continues to grow. For instance, if you were to make a $20 weekly payment into a savings account and you do not withdraw any of that money, then the amount in the account will continue to increase. A decreasing annuity is where the rent payment decreases the amount of money in the account. So, for example, if you were to make $200 payments on a loan, then the value of the loan will continue to decrease. Or another example, if you had a retirement account and you withdrew $100 every week from that account, then the value of that account would continue to decrease. So let's take a look at the formula for the increasing annuity. So the formula for the increasing annuity that we are going to use is the following. It's going to be F, which is going to be the future value, is equal to, and then we have this relatively large fraction. In the top of that fraction we have open parentheses 1 plus I, where I is the interest rate per period, raised to the n exponent, where n is the total number of times interest is compounded, and then minus 1 over I, and then all of that is then multiplied by R, which is the rent value. So here are the values of those variables. So F is the future amount, or the definition for the variables. I, to calculate I, we have to do little r, the yearly interest rate, divided by M, where M is the number of times interest is compounded per year. To calculate N is the total number of times interest is compounded, so N is equal to M times T. So let's take a look at an example. So let's say we want to find the future amount if $100 is deposited every month into an account that makes 3% interest compounded monthly over the course of 20 years. So here's the solution. First thing we do is we identify the variables. So when I read through this paragraph, they ask for the future amount. Now I see that I have a typo here. I say R is equal, we want to find the future amount. That's not a typo. If $100 is deposited every month. So R, that's the amount of our periodic deposit. That's 100. So $100 is deposited every month into an account that makes 3% interest. So my little r is 0.03. Compounded monthly, so M is 12, over the course of 20 years. So T is going to be 20. To calculate I, we have to do little r divided by M, which is 0.03 divided by 12, and that calculates to 0.0025. We need N. N is calculated by doing M times T. M is 12, and T is 20, so 12 times 20 gives us 240. We now want to plug those values into our formula. So here's our formula, plugging those values in. That gives us the future amount is equal to 1 plus 0.0025 raised to the exponent of 240 minus 1, all over 0.025, and then that's times 100. And when I did that with my calculator, that ended up giving me $32,830.20. Alright, well, one of the issues that we're going to get is how can we put that thing into our calculator? Well, there's a lot of different calculators out there. So I've actually given you some notes as to two particular types of calculators. Now, this isn't really a brand issue. It's more of a how does the calculator deal with exponents, because that's the big indicator as to which set of directions we're going to use. Now, I do realize that some of the other calculators might have some other ways to put it in, but they will most likely be able to put it in the way that I'm actually describing it. So let's go back over here. Alright, so how do I type this monstrosity into the calculator, that big horrible fraction? Alright, so there's two types of calculators. One type of calculator is going to be whenever you type in an exponent, so like this 2 to the 4th power, if you do 2 followed by your exponent button and 4, if you get a display that looks like 2 and this little caret symbol, 2 caret 4, then that's one of the types of calculators. So for this type of calculator, here's how we're going to put in that particular expression. So I'm going to do 2 left parentheses and then 1 plus 0.0025 right parentheses my exponent 240 minus 1 right parentheses divided by left parentheses 0.0025 followed by right parentheses. Now notice I'm putting in a lot of extra parentheses. The big reason why is because many calculators cannot put a fraction in this fraction format. So I have to use these extra parentheses to group the numerator together and to group the denominator together. And if I don't put those extra parentheses in there, it will not calculate to the correct value. So the display will look almost exactly the way I typed it, and then when I press either the equal button or the enter button on the calculator, that actually will give me 328.3019981. And then to get the answer from example 1, we multiply that by 100. Now let's take a look at the other type of calculator. So the other type of calculator, whenever you do 2 exponent 4, the display will actually look like an exponent. So for this type of calculator, whenever I go to type in that big fraction, I'm going to start by doing left parentheses, a second left parentheses, 1.0025 right parentheses, and then I'm going to push my exponent button followed by 240. When I do this, the display is actually going to give me the 240 written up in the exponent. And what you're going to have is your cursor is going to be up in that exponent, and in order to get the cursor out of the exponent, we're going to press the arrow to the right key on the calculator. So your calculator should have an arrow to the right key somewhere, and then when you do that, it'll put it back down on the main line, and then we can continue to type. So if we continue to type, with our minus 1 right parentheses, divided by left parentheses 0.025 right parentheses, and then if I press my equals or my enter button, I should get that 328.3019981. And then again, to get the answer in example 1, you multiply that result by 100. Alright, let's take a look at a different example. Example number 2. So here it asks the following. How much would you have to put into an account every month if the account makes 6% yearly interest compounded monthly in order to have $500,000 in 30 years? So here's the solution. First of all, let's identify our variables. So as I read through that sentence, the first number I get to is the 6%, so my yearly interest rate, little r, that's 0.06. It's compounded monthly, so M is 12. we want to have a future amount of $500,000 in 30 years, so F is 500,000 and T is 30. To calculate I, which is that periodic interest rate, I do my R divided by M. So 0.06 divided by 12, that gives me 0.005. And to calculate N is M times T, which is 12 times 30, which gives me 360. I now want to take those numbers and plug them into my formula. So taking these numbers and plugging them into my formula, that's going to give me 500,000 is equal to, and then in the numerator I'll have open parentheses 1 plus 0.005 right parentheses exponent 360 minus 1, that's the numerator, divided by 0.005, and all of that is times R. So we now have to calculate that big fractional expression. So to calculate that big fractional expression, again using my calculator, that ends up giving me 1004.515042. So when we update our equation, we get 500,000 equal to 1004.515042 times R. To solve for R, we want to divide both sides by the coefficient of R, which is that 1004.515042. A lot of times in these problems, instead of just, saying the long number every time, I just usually say the big long decimal. So we've got 500,000 divided by that long decimal, and then when I divide the right side by that big long decimal, that'll give me 497.75 is equal to R, which is the same thing as saying R is equal to 497.75. So if you deposited $497.75 into a 6% account every month, after 30 years you will have $500,000. Alright, so let's take a look at calculating that monstrosity. Well, here I'm doing kind of the same thing as I did before. So if we have one of the calculators that use our caret symbol for our exponent, then when we go to type it in, well, we type it in exactly the same way we did with the previous one. And again, what we type in is going to look exactly what's on the screen. And then when we calculate that result, that gives us the 1.004.515042. If you have the type of calculator that writes the exponents using standard exponent notation, then here's what that calculation looks like. Here's how we type that in. Typing it in the same way as we did with the first example. And then when we press our equals or our enter button, we should get the same result. Alright, now let's take a look at the formula for decreasing annuities. The formula for decreasing annuities is going to be calculating present values and rent values. And the formula looks like this. P, the present value, is equal to 1 minus, open parentheses, 1 plus I, close parentheses, raised to the negative, notice there's a negative sign, N. And all that is over I times R. And again, these variables are the same variables that we've been seeing. P is the present value in the account, R is the rent payment, and so forth. I is the interest rate per period, which again is calculated by doing R divided by M. N is the total of times interest is compounded, and that's calculated by doing M times T. So looking at an example here. Alright, so find the present value on a loan, the amount of money still owed, if $100 is paid every month onto an account that makes 6% annual interest compounded monthly for the next 3 years. So again, first thing I'm going to do here is identify my variables. So whenever I read through this, they said $100 is paid every month. So that's my periodic payment. That's my capital R. R is 100. it makes 6% interest. So my little r, that's going to be 0.06. It's compounded monthly, so ILM is 12 for 3 years, so T is a 3. And then once I have these values, I can calculate my periodic interest rate. So 0.06 divided by 12, that gives me 0.005. And when I calculate N is going to be 12 times 3, which is 36. So I can now take those values and plug them into my formula. So plugging those into my formula for a decreasing annuity, that gives me the present value is equal to 1 minus, open parentheses, 1 plus 0.05, close parentheses, exponent negative 36. All that is over a 0.05 times 100. And then if I grab my calculator and start pushing some buttons, that's going to give me a result of $3,287.10. So again, what this is saying is, if I am making $100 payments every month, and I'm going to be doing that for the next 3 years on a loan or something like that that makes 6% interest compounded monthly, then that means I currently owe $3,287.10. So if you actually have a mortgage or a car payment and you wanted to try to figure out how much you still owe on it, you could actually use this type of problem. Alright, well, let's take a look at how we can put that thing into the calculator. So how do we put this thing in our calculator? Well, again, I already talked about the fact that many calculators are different, and I've already talked about how calculators use the exponent. But this one, we have a negative symbol in there. Most calculators have difficulty with negative symbols and subtraction buttons. So most calculators will have a subtraction button and a negative symbol button, and those two are going to be two different buttons. Some calculators are going to have a symbol on the button that looks like this, plus or minus. Other calculators are going to have a symbol that looks like this on it, and that's going to be their negative sign button. So make certain you identify which button is your negative sign, because if you interchange the negative symbol and the subtraction symbol, you will not be able to calculate the correct answer. Alright, so let's take a look at how to calculate the result. So if we've got one of the types of calculators that use the caret button, then to calculate the value of this monstrous fraction, again, we type it in exactly like we would. The big difference here is this dash here, that has to be used a negative button rather than the subtraction button. So the negative in front of the 36, that has to be the negative button. And then this dash here, that one must be the subtraction button. And then again, the display will look exactly what you typed in. And then when you push your enter button or your equals button, you'll get 32.87101624. And then to get the answer that we got in example 3, we multiply by 100. If you have the other type of calculator, where your exponents are displayed the way exponents would normally be displayed, here's how you would key that into your calculator. Again, notice that whenever I put this symbol here in, this dash, that I'm going to use the negative button and not the subtraction button. Make certain you do that. And then if you continue typing and then press enter, you get your 32.87, so forth. And then to get the answer from example 3, we multiply that by 100. Alright, let's take a look at another example. So this is example 4. So example 4, we want to find the amount of money we can withdraw every month. In this case, it's still a rent payment. If the account happens to have $500,000, $500,000 in the account, and it makes 3% annual interest compounded monthly. And we want to withdraw all that money over a course of 30 years. So after 30 years, the account is empty. And if you pay attention to things like the lottery, when people win those big jackpots, they get a choice of either the one lump sum payment or a payout over years, and that payout is an annuity. All right, so let's take a look at this solution. First of all, identify the variables. Well, the present value is $500,000. The interest rate is 3%, 0.03. It's compounded monthly, so M is 12. And we want to get all the money after 30 years, so T is equal to 30. Well, using these values, we can calculate I, which is our periodic interest payment, or periodic interest rate, which is 0.0025. And N, that's going to be M times T, which is a total of 360. When you plug these values into our formula, we get 500,000 is equal to, well, here's one of these pleasant, that's my sarcasm, one of these pleasant looking fractions times R. So when I calculate the value in this really interesting, really difficult fraction, that's going to calculate to a 237.189 and so forth. So we can update our equation so that it will now be 500,000 is equal to my 237 points, and so forth, times R. To solve for R, we divide both sides by the coefficient. So dividing both sides by the coefficient, that's going to give us $2,108.02 for R, or you can also rewrite that as R is equal to 2,108.02. And then lastly, trying to put that last fraction into the calculator. Again, my same notes about the negative symbol and so forth. My same notes about the type of calculator. So if you have the type of calculator that uses the caret symbol, here's how we'd be typing that value in. Again, just trying to calculate the value of this big fraction. And again, as I mentioned, sometimes I refer to this as the big long decimal. So keying that in, making certain to use the negative symbol rather than the subtraction symbol, and that calculates to that 237 point thing. If you have the other type of calculator, the one where the exponent button gives you something that looks like an exponent, here it is typing that stuff in, same way we did a couple of examples ago. Same type of thing, and then it calculates to our 237.18 thing. Well, I hope you have benefited from this video, and I will see you next time.